What if I told you Earth has lakes you've never seen? Lakes sealed under kilometers of ice, in total darkness, under pressures that would crush a submarine. And they're still liquid. Right now, as you watch this, scientists can spot some of these hidden lakes without drilling. By watching the ice above them subtly rise and fall by up to meters as water moves underneath. Stay with me, because the real secret isn't just that these lakes exist. It's what they can suddenly do. This defies common sense. If it's around 40 degrees Celsius at the surface in Antarctica and sunlight never reaches the bottom, water should be frozen solid. But here are the impossible facts that make glaciologists speak carefully. Antarctica has 400-plus cataloged subglacial lakes, not puddles, a whole hidden network. Some of these lakes don't just sit there. They drain and refill, shifting enough water to flex the ice sheet above them. And when scientists drilled into a subglacial environment, they found evidence of microbial life surviving without sunlight, running on chemistry instead. Subglacial Lake Catalog Overview, Wright and Siegert 2012, Microbial Ecosystem, Krishner et al. 2014. So here's the question that turns this from cool into, oh wow. Are these lakes peaceful time capsules, or are they part of a hydraulic system that can change how fast ice slides into the ocean? Let's build the normal science first. A subglacial lake stays liquid for three reasons that team up like a perfect crime. First, pressure. Under kilometers of ice, the melting point shifts. Ice doesn't behave the same way it does in your freezer. Second, heat from below. Earth leaks geothermal heat upward everywhere, and under an ice blanket that heat adds up. Third, insulation. Ice is a surprisingly effective thermal blanket, so once the base gets close to melting, it can stay near that boundary. This is where things get strange, because the lake isn't just water sitting there, it's part of a plumbing system. Water at the base can act like lubricant, reducing friction and helping the ice above slide. And Antarctica's ice isn't a static block. It's a slow-moving river of solid water. Speed it up even a little in the wrong places, and you can change how much ice reaches the ocean over time, which matters for sea level. Now you might be thinking, okay, but how can anyone know there's a lake under kilometers of ice? That's the detective part. And it's honestly one of the coolest uses of Earth-observing tech we've got. One method is radar sounding. Aircraft or satellites send radio waves into the ice. Liquid water often creates a bright, mirror-like reflection compared to rock or frozen material. Another method is satellites that measure the ice sheet itself over time. If a buried lake fills or drains, the surface above can rise or sink, like a mattress shifting when someone moves underneath it. Missions that precisely track ice. Elevation and mass change are built for this kind of work. NASA ICESat-2, NASA GRACE-FO. So in the textbook expectation, you'd imagine, lake discovered, it sits there. Maybe it's ancient, end of story. But real Antarctica doesn't behave like a textbook. Some lakes behave more like valves. Quick pause. Subscribe if you want Earth science that feels like space exploration. What I'm about to reveal is how scientists track these hidden lakes like detectives, using radar, satellite breathing ice, and carefully controlled drilling projects. And the last part explains why these lakes aren't just fascinating. They affect sea level risk. Here's the story chronologically. In the late 20th century, airborne radar started revealing something shocking. Flat, mirror-like reflections under the ice, signatures consistent with liquid water. Then one hidden lake became legendary, Lake Vostok, buried under roughly 4 kilometers of ice and stretching about 250 kilometers long, an inland sea hidden from sunlight for a very long time. NASA Earth Observatory overviews of Lake Vostok. It was the kind of discovery that makes you realize Earth can hide entire worlds in plain sight. Then the controversy hit. If you drill, do you contaminate an environment that may have been isolated for thousands, maybe far longer, years? That debate forced researchers to develop cleaner methods and to plan like they were doing planetary protection because, in a way, they were. In 2013, scientists drilled into the Lake Whillans subglacial environment and reported evidence of a living microbial ecosystem. Life running on chemistry, not sunlight. Christner et al. Nature, 2014. And that's the cliffhanger moment, because the instant you prove life can persist under Antarctic ice, habitable stops meaning warm and sunny. It starts meaning water plus energy plus chemistry plus time. And suddenly Earth's hidden lakes start looking like training grounds for how we think about icy ocean worlds, such as Europa. Now push into the mid-2020s, moving into the 2026 era, and this story accelerates because our eyes in the sky keep getting better and more continuous. Instead of treating each lake as a standalone oddity, scientists can watch for drainage events, map likely connections, and turn a lake into a system. Here's the reveal: the 3 secrets of Earth's hidden lakes. Secret number 3, they're often not isolated puddles. They can form networks connected by channels under the ice. Think of it like plumbing in a house you can't enter. You don't see the pipes, but you can prove water is moving because the floorboards flex in patterns that don't happen by accident. Secret number 2, they can switch from quiet to violent, fast. When a lake drains, it can send a pulse of water downstream, changing pressure at the ice base. The ice above can respond like a heavy sliding door that suddenly got lubricated. Not forever, sometimes it's temporary. But temporary changes can still matter if they happen in the wrong places or at the wrong times. Secret number 1, they're biological and planetary analog worlds. Subglacial environments show that life can persist without sunlight, fed by chemical energy, that directly informs how we think about life under ice elsewhere. Earth is basically running a Europa test environment under Antarctica, except we can actually measure it, argue about it, and improve the tools. So yes, the answer is satisfying. Hidden lakes exist because physics allows them, and we can detect them with radar and satellites. But it raises a scarier question. If water can reorganize under ice, how predictable is ice sheet behavior as conditions shift? Just when you think you understand, here comes the twist. Not every lake signal is guaranteed to be a big pool of fresh water. Radar is powerful, but interpretation can be tricky. Bright reflections can also come from wet sediments, salty brines, or layered materials that mimic water's signal. That means scientists have to stack evidence: radar plus surface elevation changes, plus gravity data, plus repeated passes, before confidently saying, that's a lake. And there's a second complication. Even when it is water, the chemistry might be extreme: cold, salty, nutrient limited. That changes what life can do and how the water interacts with ice. In the 2026 era, that's why you'll see real debate. Do we need more drilling to ground truth what satellites infer? Or is drilling too risky, too local, and too easy to contaminate? Should we focus on safer remote sensing or develop cleaner autonomous sampling methods that feel more like planetary missions? The mystery isn't whether hidden lakes exist. The mystery is how many are active, how connected they are, and which ones matter most for ice stability. I genuinely want to know what you think. What's the most fascinating part of Earth's hidden lakes? A, the moving plumbing that drains and refills. B, microbial life in total darkness. C, the link to sea level and ice sheet stability. Comment A, B, or C. I read the comments, and I'll pin the best take, because this matters beyond curiosity. Hidden lakes sit at the intersection of climate, geology, biology, and space tech. Understanding subglacial water helps us predict how ice moves, and that feeds into sea level projections that affect real people and real infrastructure. It also feeds exploration, the same mindset and tools. Radar, remote sensing, sterile sampling are exactly what we'll need for icy moons. Earth is the training ground. The hopeful part is we're not blind anymore. We can watch ice breathe, track changes over time, and validate models against reality. Every season of new data makes the hidden system less mysterious and more predictable. But this isn't the only hidden water mystery on Earth. Next, we'll dive into how radar can see through ice like X-ray vision, why Europa might be one of the best places to search for life, and the strangest microbes living in places that should be impossible. Subscribe so you don't miss it. Thanks for watching. The most alien worlds might not be light years away. They might be under our feet, sealed under ice, waiting to be understood. Stay curious, and see you in the next one.